In the last video, I looked at several scenarios where autoboxing and boxing is supported. In this video, I want to focus on how it applies to arrays, variable arguments, and lists like ArrayList and LinkedList. I'll continue with the code we were working on in the last video. First, I want to create an array of the integer wrapper class in the main method. Integer array wrapper array equals new integer with a size of 5. I'll set element 0 of wrapper array to 50 and use arrays.toString to print out the array. In this code, I am creating an array of integer wrappers and set the array size to 5. Then I assign the first element to the value 50, and this auto-boxes the primitive integer literal 50 to an instance of an integer class. And I print this out using arrays.toString. Let's confirm the results. You can see that the first element value is 50, which we set it to, and the rest of the entries are initialized to nulls. Remember, the integer wrapper classes are really classes, and their default values in arrays are null references. Just for good measure, let's confirm we can print the object type of that first element. I'll print .getClass.getName on wrapper array element 0, and it's confirmed to be of type java.lang.integer. The JVM auto-boxed the literal number 50 before assigning it to an element in the array. We can also use auto-boxing with an array initializer, which I'll do next. Character array equals the characters A through D in curly braces, and use arrays.toString to print it. Here, I've got an anonymous array initializer that sets up an array of the character wrapper class, and then I print that array out. I don't get any kind of runtime error and get those characters printed out as a result. This is an example of using an array initializer using char literals, and the JVM auto-boxes each of those values into the array. Before I look at lists, let's visit autoboxing and unboxing when it comes to method declarations. First, you should know that this feature is supported within methods themselves, both with method parameters and method return types. I'm going to create a few more private static methods which will demonstrate autoboxing in different ways. Private static int return at int with a parameter integer called I. Return I. In this code, I take a java.lang.integer parameter as an argument and simply return it from this method, whose return type is an int primitive. Java unboxes the I argument to return the primitive value boxed in the wrapper argument as the return value from this method. Let's try things the other way around, similar to before, but return an integer this time. Return I. This method takes an int parameter and returns it from a method that's got a declared return type of java.lang.integer. An object is returned, in other words, the variable I is auto-boxed to an instance of the integer wrapper class and returned without us having to worry about writing any specific code. Putting another twist on this, we can invoke these methods, passing boxed and auto-boxed values to these methods. I won't invoke these methods from the main method. Instead, let's extend this a little, creating a method that takes a variable argument of int primitives as one of its parameters. And I'll use this method in code. Private static array list of integer getList with a parameter interlipsis varargs. Array list of integer A list equals new array list, diamond operator parentheses. Loop through our variable length varargs using this for each loop. Return A list. This method is declared with a single parameter, a variable arguments declaration for the int primitive. This means this method can be called with 0 to many int values. Inside the method, I've created a new instance of an array list with the integer wrapper class as its type in the angle brackets. You can't put just the int type in there, so this is a good place for auto-boxing. I use a for loop to iterate over the values that got passed to the method in the varargs argument and add these primitives to our array list. The add method on an array list is declared with an integer wrapper parameter type, not a primitive type. This is another way to auto-box. Finally, I return the list we created from this method, and we want to call this new method from the main method. Var our list equals getList, passing the numbers 1 through 5 as arguments, and print it out. I'm purposely using the var keyword here because I want you to see the IntelliJ hint. I have this turned off at the moment so nothing is showing. Let me show you how to have it show in IntelliJ. Come up here to File and select Settings, type Inlay and click into Types. Then click into Java and check Implicit Types, which I will do now. Finally, I'll click OK to go back to the code and notice the return type hint is showing now. It shows we're getting back an array list of integer, and we get confirmation of that on screen. Now, what if I change this method to take a variable argument of the integer wrapper class? With this change, everything still compiles and runs, even though in the main method we're passing literal int values. This method's expecting integer instances, but the JVM will again auto-box everything in that variable argument list. In a way, this means we can almost use primitives and their corresponding wrappers interchangeably. What this means is that for factory objects that create lists, we can create lists from primitive literals, as we did here in the main method. We can simply replace this call to our custom method with the list.ofFactory method, which I've talked about previously. Remember, this specific method returns an unmodifiable list. Note when I do that, the inlay hint updates to show a new return type from the list.ofFactory method. Okay, so let's end our discussion about autoboxing and boxing here. In the next video, I'm going to give you a challenge to apply what you have learned. I'll see you in that next video.